All right, we ready? Fantastic. Hello, everyone. I'm Michael, again, co-founder, senior consultant at HanaByte. And my first question here today is going to be, who's familiar with FedRAMP? Few hands, CMMC, NIST controls, fantastic. That is perfect. So for those of you that aren't familiar, FedRAMP is a program that is designed to help the agencies in the government, let's think three-letter agencies for this case, to use modern cloud technologies, right? So they want to have a program where we can go through a set of steps, make sure that our solution is secure, and then it will give us an authority to operate so we can list our cloud product or service on the federal marketplace. In the bottom, you can see there's a few quick steps there. We have our preparation, authorization, and continuous monitoring steps. This talk will cover a large portion of the preparation, and then additionally, the tool does help with the continuous monitoring phase as well. So what is an ATO? An ATO is just an authority to operate, right? What happens here is once you get issued the ATO, we now need to continue the monitoring of our environment, right? So we've gone through the process. We have been sponsored and we've gotten our FedRAMP compliance set, and it's like, okay, government gives you ATO, you can now sell your product on the federal marketplace, but you can't stop there. Right? You can't stop monitoring and making sure that you abide by the guidelines because you can lose your ATO, right? So in our experience, rewriting a product doesn't work very well, right? So think about the fact that you would already have your application, you already have an environment set up, and you're now thinking, oh, I need to go for FedRAMP compliance. The problem with this is you're either going to have to include your entire setup in your boundary, or you're going to have to create something new. Right? So if you have to create something new, which is usually the route we go, right? We found it's much easier than bringing all of this stuff in, especially in very complex environments. If you have 30 plus AWS accounts, that's a big haul, right? That's a really big task. So what we want to do is standardize a starting point, right? We want to have a landing zone to streamline the process. That leads us to AWS landing zones. You're probably familiar with Control Tower and you kind of know how it works. So, but if you're not, so for AWS landing zones, we like to build out a well-architected multi-account AWS environment that's scalable. That can be kind of difficult if you're using Terraform or if you're using Control Tower, got to do a lot of ClickOps there. So we decided to look for a starting point. We either need to do it ourselves or find a tool that already exists for it. In that case, we want it to be secure and compliant. And like you'll see there is a multitude or plethora of options that you can use to do this. The one that really spoke to us was AFT, because I realized in having AFT, we could do this code, or we could write this code and make it AWS native because it will use code commit. And that was a big thing for us, is how can we do this in AWS only? And then, is there some sort of robust solution that will allow us to use things outside of that? Like with AFT, we can use GitHub or we can use GitLab in addition to that. So on top of that, AFT is going to use Control Tower in the background. It's really just an account factory. It's a provisioning tool, right? It's going to help us deploy a bunch of different accounts and establish guidelines for those accounts when they are being created. Okay. Cool. So what does AFT do? This is the cool part. It sets up a Terraform pipeline to provision accounts or provision and customize accounts, right? So we are able to take Terraform, write it out, have our account structure stored in the back end of AWS, and you are now able to provision new accounts through writing code, right? Which is great because it goes into our code base. We can do our code review process. We have our peer review, and then we can create the new accounts, have all sort of security controls around that. Exactly what you want when you're creating new accounts. And in addition, it does support Terraform Cloud, Enterprise, and OSS. The cool part about this is it is also working as a GitOps model, right? So what's going to happen here is you are going to make a change. As soon as the PR goes through, AFT is watching for that PR to hit, and when it does, the changes to our accounts will go through and begin creating in our pipelines. Like I already said, works at GitHub, works at GitLab, and then lastly, it reduces the workload of GovCloud account creation. This is a bit of a tricky one. If you're familiar with creating accounts in GovCloud, right, you're going to have to go through Cloud Shell or some sort of CLI, having a different set of permissions, and make any accounts. It creates the mirrored account on the commercial side. But once you have those accounts created, we can then, or let me rephrase that. Once you have the accounts needed for AFT created, you can then go ahead, add it in, and start provisioning accounts from there in GovCloud using AFT as well. So this is not just a commercial solution. Should note for this case, I did go through the commercial side because it's a bit easier. So what you're going to see today is just kind of commercial walkthrough. Do not expect this to work in GovCloud. This is the AFT workflow. Pretty complex, right? It looks complex, and it is. And what makes it so complex is that there's going to be a lot of step functions on the back end, right? So at the start, not really hard because you make a new account request. How do you do that? You have a repository and code commit, right? Easy enough. You make your PR goes through, kicks off the account request pipeline, and next thing you know, we now have an account being made, right? But once that account's made, there's going to be a slew of pipelines that pop up behind it because we need to have things like an account request pipeline, right? We need to make sure that when we request account, that's all that that's doing. Or we need to be able to provision resources. How do we do that? Through customization. We'll have a customization pipeline, maybe a global customization pipeline. And in addition to that, there's also a provisioning state machine, and the provisioning state machine works very specifically with third-party tools, and if you want to bring something in before your account is set up. But yeah, so once we get through that workflow, I want to take a quick second to talk about the security reference architecture. So the reference architecture, we use this at HanaByte. We have our own version, and as we've gone through multiple FedRAMP and CMMC engagements, we realize that it's not going to fit every single client. Not a problem. It's a really good baseline. This is found in the AWS documentation. You can go look at this at any time that you like. So in doing this, this reference architecture is very important for how we like to establish guardrails, right? We make sure that we're using a management account. We have all of the admin stuff delegated out to a security account, and we're just really making sure that blast radius is controlled and the access is minimalized. Now, Control Tower. So this is where we get started. This is a bit of a tutorial here. So the first thing to do is to set up your landing zone, right? Going back to the AWS security reference architecture, as you can see, we have the payer, audit, logging, and AFT management accounts. You will not see the AFT management account in the SRA documentation. This is something that we have kind of had to add in on our own, and it's obviously suggested, and you need the account, but we're putting it in the SRA just as a kind of a customization that we did. And so what we're going to do is you have to create your security OU. Once you have the security OU, you then create a second one that can be infrastructure. This name is really optional. It's not something you have to worry too much about. But yeah, so we have our 2 OU set up, and then as we continue on, you're going to add 2 accounts, right? We need a log archive account, or an auditing account. This is commonly crossed with the security account. They are the same thing. And then additionally, we want to have another OU that I'm not to yet, but continue on here. Yeah, so now once we've got all of this baseline of accounts, we can start working with the AFT. And so you might be wondering why we need these accounts first. So AFT requires these to be set up. You need a lot of information for Control Tower, and that's what AFT is doing, right? Like in the background, you're going to have this Terraform file, and it is going to fill out the fields you would be filling out in Control Tower. Before that, one quick thing here is storing your AFT state, right? So this is a big deal. You're obviously going to need state for Terraform. This is one that could honestly be debated. There could be a question about this. We personally store it in the management account. This is one that it's kind of a one and done situation. Once you have your accounts built out in the management account, you really don't need this afterwards. We don't want to see a lot of changes here. But yeah, just a quick policy there. If you want to use it, feel free. And now we get to start takeoff. So in this example, I pulled from version 1.10.4. This is a little bit out of date as of today. However, it works really well with our setup, and we really like it. So I'm going to stick to this for now. But a quick piece there. Yeah, you're just pulling from the AFT module, right? We have the source, we're using the version, and then now this is where those accounts come in, right? So we set all this up already. We created these accounts. We use Control Tower to build this stuff out. Now we get to import it in. That way AFT can be controlling and registering in Control Tower. So yes, we have our 4 accounts, and then we also have our home region and a Terraform backend secondary region. Continuing on, we have optional parameters. So like I said, we can use code commit, we can use GitHub, we can use GitLab. Those things you need to specify in this version, and some of the new ones you don't. However, the variables are still there if you want to. And then additionally, we have a few things here at the bottom. These are more optional feature flags. We've noticed that some of them don't work in this version in Control or in GovCloud. That's just purely an API thing. The tool is not defective. It's just something that we can't do. And we're kind of getting out of the balance when trying to set up some of these extra optional features. So account requests, the 3 C's. Go commit. So what's going to happen after we have ran our Terraform code? The state is in our management bucket. Everything is beginning to set up. We're going to have 4 repositories that are going to be created or need to be created in code commit. It's going to be our account request, right? That is if we need to add a new account, right? So in that security reference architecture you saw, or if we go back to it, there would be a workloads OU that we create in addition to all of this later down the road. The workload OU does exactly what it's named. It holds our workloads, right? So we have our production, dev, UAT, whatever you may name it, it's all going to be right there. And so we have the account request because we're going to want to request new accounts, right? That's the whole purpose of this tool, is we want to be able to build out, oh, we have this new app. Well, then let's make a new account for it. Let's make that blast radius small. Let's keep it within the boundary. And that's how we do it through the account request. And then we have the account customization. So account customizations are going to be very specific customizations for that account, right? There's going to be one pipeline per account you create. You're a little hefty. I know it's a lot of code there. And then, as I said earlier, we have the provisioning customizations. That's just third-party stuff you want to do before your account's created. And then lastly, we have global customizations. This is a very nice one. This helps us establish guardrails in the accounts at a very high level. We can add a global customization, and when we do, we then run against all accounts, and we've now applied. So for example, think password policy, right? If you need a password policy, you can put it in the global customization, and then it will go across all of your accounts at once. And then code pipeline. So you'll have 2 pipelines created for you in code pipeline. A, the account request. Obviously, you already know what that does. And then the provisioning customizations, right? These pipelines, again, they use the GitOps model, as I mentioned earlier. Once the code's added, we submit our PR, pipeline runs. Then we have cloning. So the code commit repos are empty at the start. What we do is we create the account request repos, right? And then we have to copy and clone the code into a code commit repo, right? And then we kind of remove the example folder or any templated code that we might have in our public repositories. This is what it's going to look like, right? So if you are going to follow this along later, this is how my VS Code terminal or IDE looked, right? So I pulled the account request stuff down. I now have a small folder with modules and our main Terraform file. So let's make all of the accounts. This is, like I was saying, we have workload accounts. We need to make a new one. This is how we do it. We use the module, right? We import the source as just the account request. And what's going to happen here is you're going to need an account email. You'll need a username, just basic control tower stuff that you would be entering. And then lastly, we have some account tags, some change management parameters, just all more, tagging kind of stuff that we can really not worry about too much. But the one thing I do want to worry about is the account customizations name, right? So that is going to be used later on down the road. We're going to have to match that against some of our code, and we do not want that to be different because then the pipeline won't run. So one small caveat. Now, with this version, I did notice that there is an issue with the backend file, and one of these versions or one of these variables are off, so we had to implement a Terraform version in there. I believe this has been corrected in newer versions if you use them, so you might not have to worry about that if you bump up your versioning a little bit. And then now we can go on to customizations, right? So we've talked about creating the accounts. What are our customization types? Provisioning, customization, right? So this provides flexibility to customize the provisioning process for your accounts, like when the account is being created before things are set up, right? We can integrate the systems prior to that. For this presentation, these can get a little complex, so I'm not going to do any of these just to save time. And then, as I talked about earlier, global customizations, right? Password policies. Maybe you want to implement encryption in all of your accounts. A little bit of a foreshadow here, but you want to say in AWS, make sure that all EBS volumes are encrypted by default. This would be a really good place to do it, right? Because each account gets a pipeline, and we can run all of those pipelines at once with the global customizations. And then just account customizations. These are for in-depth account level only customizations, right? Like, so if you need all accounts to have an ABS volume encrypted, that's fine, we would use global. If you need a very specific, say EFS share to be encrypted, we would use something like that in the account customization spot. Now, how does this directory structure look like? Right? So we're gonna have a few different things. You have your 4 directories, right? We have our account customization, provisioning, requests, and global customizations. They all sit at the same level in the folder hierarchy. And you can see on the very far right there, kind of what that looks like in the terminal. And it gets a little messy, I'll be honest. It's a lot of stuff in one spot. But we need to clone these down and do the same before with those repos, right? So like we said for the account requests, we cloned code in and deleted some of the like the templated stuff in there. And we're gonna wanna do the same for the other repos, right? Just to make sure the setup looks like we see on the right. All this code is provided online. You can get it from HashiCorp, you can get it from AWS. HanaByte has a public repository with all of it in it. It's an issue when working with these state machines. It's going to be a very long process, especially if it's the invoke customizations, because it is a series of machines, one after another, doing small steps when you're provisioning. I'm not really going to get into that. Just wanted to give you guys a heads up if you ever come across it. And then we have, let's see, at the bottom right, you can kind of see how this is structured, right? So we have a target value. That target value I have listed now is a very specific account. It does not have to be that way. Like I said, you can use all accounts at one time. This is where we would do it. So what happens is when you're pushing the provisioning code off, it kicks off the customizations pipeline, which creates those 4 machines right there. And then the customization machine is exactly what we use to begin running the codes. Do not run this if you're following along in this step. Nice. Now, global customizations. Important, right? If you want to feel like Mr. Worldwide, we're going to have to go global. So in this case, what we're going to do is set an IAM account password. Again, foreshadow a little bit there. And so how do we do that, right? So the first thing we're going to do is add an IAM file to the AFT global customizations folder. And what that folder is going to look like is this very simple snippet of code, right? There's not much here, but with this small piece of code and a couple pipelines, we now have, I don't know how many accounts, maybe 10, for example, that all have this password policy implemented at once using a GitOps model, right? We write the code once, we apply it 10 times in this case. Very powerful. And then we have an account customization. So, like I said earlier, that name matters that we use when we are making an account request, right? The account customizations, you have to have that account template name stored right there, and that's why we changed that value previously. And so what we want to do is once we've created this folder, we will now add a file called ebs.tf, and what we're going to do in this is turn on EBS encryption by default. You can do this in the global, just for the sake of the example, I'm doing it in a single account in this case. Very simple stuff right here. Like we just have a caller identity call out. It's a data call in Terraform. And then we have our AWS encryption by default resource. Very simple, just one Boolean value in here, enable equals true. And then all we need is a KMS key. I'm not saying this follows best practices on the KMS key. It is an example. Feel free to limit your permissions as you would. Once we have that in, then we now create our KMS key policy and we can attach it. So in a few simple steps here, we can, for example, let's say if this is a global customization, we would now have encrypted EBS volumes by default across all of our accounts, right? Very powerful again, because when you're going through these different types of compliance, you're going to have to implement a lot of these guardrails in every single account. And how do we apply changes? So our customizations, what we're gonna do is we're gonna push the IAM file and EBS files up to their respective repos. Again, it's a GitOps model. Changes don't automatically take effect. We have to create the PR and we have to run invoke customizations, right? So once the code's merged in, we can go in. This is doing it by hand. I'm giving you an example here where we're not running with the GitOps model. But you go into invoke customizations. It's the state machine that we looked at earlier. And so we want to ensure that that account number matches in this case. This might seem a little confusing because we haven't really looked at what the pipeline looks like. And so what happens in code pipeline is there's multiple stages. One of those is the global customization stage. That happens at the top. This is the first thing that iterates. And then once that is completed, we will then run our account pipeline. Right, so these things happen both in the different phases. So code pipeline reaches out to code build twice. Right? And that's why I'm only doing one account in this case, because what's going to happen is when that is invoked, it's going to run the global customizations against my singular account right there. And it will apply my IAM password policy. And then from there, it's going to run that next code build job where it's going to apply my EBS file. Let's talk a little bit about landing zones and maintenance. So with that, once you have followed these steps, your Terraform is going to go through, it's going to apply, you're going to have these resources built out. In doing that, you will have successfully set up a landing zone, right? It's very quick and easy to set up a landing zone using this tool. You're going to have small periods of time where you're running something and especially when considering Control Tower, it's going to take 30, 40 minutes, but it's much shorter to run a few things and have a landing zone in approximately 2 hours if you're quick with it, right? And that's really hard to do. Yeah, and so one of the other things I meant to touch on here is the EBS encryption by default, right? FedRAMP is obviously built on top of NIST controls, and one of the NIST controls it satisfies is for encryption. So again, really powerful. We can use the AFT tool to implement a lot of these guardrails at once. And yeah. So the next piece here is the ATO. When we have an engagement, we will go through, we'll build out a landing zone, and we then create the accounts needed. We add the workloads, set up DevSecOps pipelines, all of this stuff, and that's great. But from there, right, if you pass this off, or if you're going to use this yourself, your developers are going to be doing things in the background, and you might have missed a guardrail somewhere here or there. And the problem with that is if you're going to go, like you have to keep your ATO up. You have to be on top of the maintenance of your environment. And that's why I'm a really big fan of AFT, because I can go in when I find one of these guardrails that are missing, when I see something happening that I need to correct. All I have to do is write a PR. It's a little bit of code. I then go through the peer review process, and off we go with the pipelines. Like, this completes the job for me in a very short amount of time. I am a little bit early there. Yeah, so I'm Michael. This is AFT. I am, again, co-founder, principal consultant at HanaByte. There's my LinkedIn at the bottom there. And yeah, does anyone have any questions, or is it time to take questions?
Yeah, if anybody has any questions here in the room, we'll bring a mic to you. Just raise your hand. We do have some questions already here in Slack. And the first one is, hey, with using AFT, have you run into any scaling issues when you've got hundreds or thousands of accounts?
Hundreds or thousands of accounts? Yes, you do. This is a really good question, actually. At reInvent last year, there was a talk about a tool kind of matching this, and one of the guys in there is running this with, I think he said, around 1,000 accounts in their organization. Yeah. I mean, it is difficult. It is going to be messy when you have thousands of accounts. But what's your alternative, right? Like, how are you managing those in the meantime? Because if you create your own modules, right? We have our own landing zone. We have a proprietary landing zone we've created as well that we use sometimes. In doing so, it's a lot of text that goes into managing this. So I guess from a bias point of view, in this case, me, I don't see it as a bad thing. I see it as cluttered, but powerful, I guess is the best way to think of it. So yeah, you're gonna have those issues. There's gonna be clutter, but managing it in one spot, that, that I'm thinking about it, the cost of this too is definitely something to keep in account, because with AFT, you're gonna build out pipelines for each one of those accounts, and it's gonna be a lot of state machines. So, now This is a really good question. I'm going to say don't use AFT in this case. I would look more to some sort of proprietary solution. I think I've seen a few out there in our research of other landing zones where they have a massive file that kind of keeps track of all the account information and things like that. And you can go through that way. So there's just multiple ways. It's really hard to find one single solution for the 1,000 account, 10,000 account environments, right?
Cool. And getting FedRAMP certified could be a little bit of a tricky or picky process. Is that certain services are, FedRAMP compliant or not? Have you run into any nuances there that are related to accounts or other services where, hey, you suggest using some services versus others, specific challenges with attaining that certification?
Oof. It's a tough question. A little loaded there. Nuances in FedRAMP are that's kind of they go hand in hand, right? Um, just I don't really take a look at it from the service perspective. It's really for me. It's what are we trying to solve? Like what is the problem? What do we need? And how do we best do that? And how do we keep it within our boundary? Right. So when it comes to that, it's really hard to say, right? So how would we, I'm trying to think of an example of a service internally that we would pop out of the boundary for some reason to use a third party tool, but kind of blanking on that. No, no, I would say stick to knowing what your boundary is, understand what your workloads are, what your requirements are, and then work around that, right? Because there's just not going to be one solution when it comes to FedRAMP. Or let me say, there's not going to be one solution where we're going for FedRAMP ATOs, right? There's no one piece. Like for example, you might find what is it? You can run Terraform Cloud, right? And you can also, I think, run Terraform on a local hosted machine or maybe Spacelift on like locally in your environment or a self-hosted Spacelift instance, right? And in doing that, could we use code commit? Sure. I mean, sure. Yeah, we could manage our Terraform modules in code commit. Do we really want to do that? The answer is no. So in that case, I guess that's one example where I think I would use a tool is say self-hosting Spacelift internally would work for me.
All right. Now you mentioned code commit. Kyler mentions that AWS has decided to deprecate code commit for new customers. Any plans to migrate over to something else, use something else, update the tools? Any issues using GitHub or another code repository?
No, there is not. Great question. So there's a connection in there. It's intriguing. I meant to look into this. I saw that the other day that it's being deprecated. So I know for GitLab, the structure is that it mirrors across, right? And so and I think that's for GitHub too. So like we can set up our repositories in GitHub or GitLab, have all of our AFT code in it, and then it will mirror into code commit through CodeStar. The question I would need to go research real quick is if CodeStar will be implemented or allowed for new customers beyond that point when code commit is deprecated, because it technically falls under code commit. So I'm going to assume uh, no, I'm going to assume that that connection will be gone, and in that case, not entirely sure, honestly. No forward-looking plans on that yet. Like I said, we have this way of doing it. This has worked really well in CMMC environments and in kind of like smaller workloads. So for the larger ones, we have our own proprietary landing zone we would use, and in that case, not going to be relying on code commit. We'd be using GitHub or GitLab.
Yeah, it is all just Git after all under the hood.
Yeah.
Hey, one last question here. Eric points out that the customizations feature is really cool. And you had a configuration, you showed some Terraform code there where you removed the default VPC and the elastic block storage encryption enabled by default. Those are some good best practices. Are there any other defaults that are useful to consider?
Other defaults. What can I say? Encrypting S3 buckets would be a really big one, especially because a lot of our state's going to be stored there, right? So, yeah, it's tricky with this tool because if you get too far outside of provisioning accounts, you get into a place where you're now essentially building out your workloads with pipelines that weren't really created to do that, right? Yes, it's a pipeline, and we have used it in that way. That I'm saying this because I have used it in the manner where we did not add any additional pipelines on top of it. We actually built out an environment solely with AFT. Very tricky. A lot of pitfalls on that one. It was a very strenuous process. And so, do I want to do a lot of these other things in AFT? Mm, debatable, right? Like that's really up to your, like, if you're very technical and you have a lot of experience in the field and you understand Terraform well in AWS, go for it. And yeah, but so as for specific ones that I would do from a global level to hit across NIST, I can't think of one off the top of my head at the moment, but there's so many controls in the NIST framework, especially when you're going for FedRAMP, right? If we're looking at the NIST controls for that, there's going to be a bunch of other stuff in there. Apologies, I don't have the exact example. It's a good question though, and I will make sure to have that queued up for next time.
Great. All right. Michael, thanks a lot.
Awesome, thank you.